I mean, you realize very shortly after the Wright brothers flew, a few years after that, these things were being used as war machines.
Wright brothers first flew in 1903, and they were being used in World War One 10 years later.
Yeah.
That's progression.
Germany and France were building flying machines that were working at the same time the Wright brothers were. But the advancement, I mean, they might have been throwing the bombs out the door, like out of the canopy, but they were still using them. But if it was linear, but what happens in space technology, it's like bringing water to a boil, and it doesn't get any hotter. Once it reaches boiling temperature, the temperature doesn't rise anymore. And it doesn't matter how much more energy you put into it, it still doesn't get any hotter. That's space travel. You get to that stage, that's as far as it's going to go. But they're being taught and they're being shown. They're showing CGI images, everything else. All of these future technologies that are supposed to be traveling in space, but they can't take a photograph of it. They show us CGI.
Never mind CGI. Look at what we were looking at yesterday with Apollo 7. Let's just take a look at that for a minute. When a movie's going through a projector and you project that onto a wall or silver screen, doesn't matter. If the speed of that projector is not set right, you could see the bulb flicker, especially when it gets to the whites. So look at it. I'm going to show you something here. When it gets slow, this is what it does. Look at all that flashing. That's not normal. And then the horizon, this gets bigger. This, and then it shrinks again. It gets bigger and then it shrinks, the edge here. It makes no sense. You look at the flickering in the whites. Very bad.
Yeah, not to mention the spots and everything else that are going on there.
That's just an old film, but it doesn't matter. I mean, this is projected onto a screen. There's the window. All right, now we can take a look at a simulator that was on the ground. And then you're going to see the same thing in the simulator when the astronauts are looking out the window. Yeah, look at it. There it is there. That's what you're seeing there. That's the surface.
If they've taken it using that simulator, that image there, and they're sitting looking at it in there on the screen, the screens that they're looking at, that image that's on those screens, are as good as any orbital photograph or any orbital image that they've ever put out. Look at those images that are on there. I know they're tiny to see like that. That looks exactly what they claim to be the real thing, as that orbital image. I wonder what they're going to sell that thing with all of the missions on it, that board.
Oh, that'll at least be $100,000 just for the writing. How do you know if these photos he's holding here are actually from this?
No, they're from the simulator. Everything's from the simulator. All their maps that they took, where do you think they got their maps from on the rover? How could they produce the maps when they're just getting there for the first time? Good question, eh? What they claim is they couldn't reproduce the surface of the moon. They couldn't fake it. They couldn't reproduce it. And you're sitting there looking at one of their own reproductions of the lunar surface that looks just like what they claim is the real thing. There is no difference.
Now, don't forget, these are coming through on CRTs, cathode ray tubes. There's other simulators that just have projection screens out the windows. Right. Those are the ones that when they flicker are the same thing you're seeing in the Apollo 7. That's when they cannot claim that it's camera flicker or sync rates out.
But I mean, the other one with the Earth and the clouds and everything else, they could do that off of a balloon. They could record that image.
The joystick that's sitting in the simulator, that's what those guys, when they're going like this and turning the joystick, this camera, the whole mount, this is what it's moving this way and this way. The only thing that's tilting is the camera. Everything's on that mount.
Yeah, and they said that they didn't have the technology to fake it, eh? And there it is right there. They're looking in a simulator at what the lunar surface should look like, and it looks exactly what they presented for all of the missions. It's right there in front of them. Oh, I like his sunglasses. That's why they needed to put the pocket in the spacesuits for these guys. I guess they were addicted to sunglasses like people are to cell phones today, right? You can't set them down for a minute. You got to have a pocket on your spacesuit, you know, so you flip the visor up on the moon and put your sunglasses on and everything's just like James Dean cool.
In any case, and then you have the other simulators where they're looking out the window and it's a projector. It's actually a projected image, not a cathode ray tube. Again, there's all different types of ways of doing it, but these guys, I mean, come on, they're broadcasting this video right to those television sets. Well, guess what they had in the 60s? Television sets. That's what we were watching ours on. Right? So they say it can't be faked, can't be done. No, there's one of your orbital shots right there landing, coming into land. You put that up against one of those shots where they're inside of the LEM going down. That's what you're going to see.
If they wouldn't have gone to all the trouble to build that 20-foot ball that rotates, they wouldn't build the track around it. They wouldn't build all the half sections of it that they were working with on there. What were they doing with that? That has nothing to do with getting a rocket off the ground. Nothing. Absolutely nothing. You think about that. Why did they have to do all of that? Doesn't make sense. I mean, if you build vacuum chambers, you put the equipment in, you put the people in, you put everything in, you test everything. That's one thing. And at least 10% of their budget was on that. The rest of it, you're building rockets and a launch pad and everything else, and trying to make fuel tanks and oxygen tanks, figure out how much power you need. Where did all of these plaster molding and stuff like that, why did they need to do that? They didn't have to reproduce the surface of the moon to practice landing. They didn't need to have orbital photographs to practice flying it. They could have used anywhere on Cinder Lake and said, this is it, and don't have to reproduce it to make it look like the lunar surface.
Now we're going to take a look at a different simulator. Now have a look at this one. There's another one for you. So yes, they can do it. This because that's supposed to be a landing spot that they forgot to erase. It's interesting, all this. Look at all these simulations and the trajectory, land, maneuver, alternate.
Those are all just simulations that were developed.
But look at this. If this is, again, what's this doing here? That's a marker.
Well, it's just alien shit that was out there. That's why they profess that there are aliens inhabiting the moon all the time, right? They continue with it.
But it's good. It's pretty good stuff, though, for a camera just running over a mold.
It looks at least as good as the landing from 11, 12, and 15. That was kind of a screw up. They didn't do a good job on 15 because I dropped the damn thing off the gantry crane.
That's why it's so much harder to do it for real than it is to fake it. Because they keep saying it's harder to fake it than to do it for real. No, it's not. Look at this information. It's harder to do it for real than it is to fake it. Faking it's simple.
Well, like Neil deGrasse Tyson going, well, why did they use all that fuel if they weren't going anywhere? Well, it only lasted 2 minutes and 42 seconds. So then what?
Neil deGrasse Tyson genuinely believes that they got to the moon.
Of course he does.
So everything that anybody says that contradicts that, he's going to find an answer to it. And he's an important person.
He never actually answers a question.
No, he doesn't answer the question.
He asked you another question. Like, as you ask him if they went to the moon, and he says, you know how much fuel's in that rocket? Are you kidding me? Would you put that much fuel in there if you weren't going anywhere? And that's exactly how he says it. And it's, well, Neil, it's 2 minutes and 42 seconds. You're nowhere near the edge of space, and you are done.
This is the one that I wanted to show. This is the LEM. Now look at that. This is a projection on the outside from this camera here.
Yeah, they're looking at it on the screen out through the window of a simulator.
Look at that. And here's the camera right there. And there's the LEM.
Oh, look. How do you get out that door with that console there?
No, Scott, don't ask embarrassing questions.
How does Buzz stand up in there?
How does Buzz stand up in there? Yeah, there you go. There's the door. There's the console right there. How are you going to be standing up all... Exactly.
I know. And they expect us to believe it. A lot of people do, unfortunately, but we don't.
Well, you see, if you say one's a simulation and the other one's the real thing, but both of them are simulations, you can either claim we really did a great simulation, or they claim that they couldn't do a simulation. Both of them now have to be real because they both look the same, because both of them are actually simulations. So what they need to go back is they need to re-record some really lousy simulations and put those up and say, this is the best we could do in the simulator. But they didn't. They got them up there. Periscope Films got their simulator, claiming their simulator, that are equally as good as what they claim is the real thing. And it could actually be the same footage.
Yeah. Interesting, they called themselves Periscope Films, when a periscope camera is specifically designed for doing miniature sets.
Yes.
Very, very strange. It's almost like they are so arrogant, they can't understand why people can be not fooled by what they're doing. All the little bits of, all the details, and we can put them all together. We can ask a question. Oh, that's the, oh, I recognize that. There's the globe. It's supposed to be in San Francisco now.
And how big is that piece that's sitting there? Like 6 feet across, that first set?
Like that, yep.
I guess this is a model of it.
That's just a model of it. And then they built the 10-foot high panels like that they're working off of there.
Then they used a camera on the tracks approaching it. There we go. That's the original.
291 square feet.
Oh, it's live from the surface of the moon, guys. They must be real. Or not.
You've seen pictures of them working against that 10-foot model, but you never see them with the miniature model of what they're going to produce. And
No.
They obviously planned that well in advance, presented it to a board and say, okay, we're going to do this to fake it. But yeah, your comment about Periscope Films, the fact that that technology was used to do models for all of the aerial photographs, for all the orbital photographs that they were doing from Earth and Moon would have been shot like that.
The sequence you've used before, Robert, where you're showing a miniature set with the camera, and it's a big thing. It comes down onto the set. Then you see the result projected from that camera. Well, filmed from
Oh, John Dykstra.
That's the one, yep. And it was probably also a technique that was used by Douglas Trumbull.
They have so many simulators. There's another, like, I mean, it's crazy. What the heck you need all this stuff for?
You don't. That's the whole point.
I mean, I could see them building 2, but 5, 6, 7, it doesn't stop.
Why, if you're building a simulator, why do you have to have the image of anything of the lunar surface to practice? What you should be practicing is a target, like measured speed, descent speed, ground speed, and your descent speed to control those engines coming down. If you're going to be landing that LEM, you should be practicing that. The surface below is irrelevant to you at that point. You only need to control the craft, right? You would put a target up.
Well, they wanted to be as accurate as possible.
Oh, yeah, but they knew that they were going to have to go around this little crater and over to that one. Bullshit. They do a good job promoting what they do, but the price they charge to do it is unbelievable. That's the part that pisses me off. I mean, you can go out and shoot your mouth off all day long, but people don't have to pay you to do it.
It's sad, really.
What's he at? $150,000 an hour for a Skype chat?
Yeah, it's ridiculous.
Not from us, he's not getting it.
No, not in this lifetime.
No.
Considering the fact that he doesn't have anything to say, that's an awful lot of money to pay for entertainment.
But he says it very well, don't forget.
We have something to say. People should listen. They should understand it because it's important.
I think a lot of people are listening now because the Artemis program is such a farce right now. And Elon Musk is really not succeeding in getting his rocket off the ground. People are saying, well, if it really was so easy back in the 60s, what's the problem today? And we see the problem today. It's not easy. And I think a lot of people are beginning to realize that what we have to say and the archive that we have assembled, or Robert has assembled so successfully, will become a go-to place for people who are beginning to find out that Apollo was faked. It's quite a hard thing to accept. If you've always thought Apollo was real and you suddenly are now confronted with the fact that it was not real and was faked, that's a very hard thing to accept, especially if you've believed that for most of your adult life. You know, the people 50, 60, 70 years old who still believe it because they remember when it first happened. And to turn that around, to turn that attitude around, takes a while. People do get there, but it takes a while to do it. And I think we're helping that process.
I think what people need to get to the point is that we should take our energy and technology into something more practical. On a world-wide basis, I think our healthcare industry needs an entire overhaul and pay attention to it. Why not advance it? Why not make our lives more comfortable? Because anything that's happening in space is for an individual, not the general population.
For the rich and the greedy.
Anyway, we had robots on the moon with the first man on the moon. Yep. Isn't that incredible? And the media was focused on the people, not that. I had no idea that there was media on the moon. They certainly were not controlling the cameras, were they? Like, did the BBC, were they there?
No, the media always gets there first. You should know that.
But here we have a man who has some notoriety in a subject that is totally unrelated to anything to do with scientific knowledge whatsoever or physics. He's a theoretical physicist. He doesn't know anything about physics. He doesn't know anything about the Hadron Collider. And yet, because of his notoriety, they think that because he can say the God particle out loud, that he has some involvement with it. The electrical engineers that designed that, the amount of power that that thing needs, those are the guys that should be on stage, not him. And when it comes to the moon landing, he can talk about his imagination all he wants about space. Yep. Nobody can disagree with it because it's his imagination on how he views the galaxies, outer space. Nobody can disagree with that. Yeah. But when it comes down to real physics, he doesn't have any qualifications to discuss it. But because of his notoriety, they think he does.
Well, at least he's getting a good workout because his arms are going this way and he's jumping out of his seat and has to be pulled back again.
But these robots that were on the lunar surface with Neil Armstrong, if there were robots running around there, if there was rovers running around there, wouldn't we see the evidence of that on the ground? Wouldn't we be able to see their tracks running around?
Oh, we should be able to. Yeah.
Right? He's talking about the moon landing. He doesn't have any more knowledge of that than he does the Hadron Collider. It's not his field of expertise. He hasn't looked at the photographs. He hasn't read the documents. He hasn't read all those PDF files on the design of the stuff. He's never put his hand on a wrench and turned anything his entire life. He's a documentary host, and he's very good at that.
He's a performer as well.
Well, he's entertaining. He has an appearance, his face, everything else. Like, he's right up there, like, as far as I see him, you know, he could be on the Muppet Show with them because he has that animated face to go with it, right? That's the attraction. The guy said, these are absolute facts. You can't argue with the facts. And he goes, watch me, right? And he goes off on a different tangent. They never discussed the topic that they were on any further. He just went off on a budget or something else. And then he's claiming that NASA gets a whole lot more money than it took to put the Hadron Collider together. Well, does that mean that those guys were underpaid that put it together? All those real guys that designed it and built it and can control it? I mean, that's an amazing feat. Those guys did some amazing work to control that much energy. I mean, I was reading an article on the Hadron Collider, and I said, just to stop the flow, it can melt 6 tons of copper. That's how much it takes. That's how much energy has to be absorbed just to stop the flow. That's some pretty dangerous stuff you're working with. This particular gentleman knows nothing about that. He doesn't even know how big the thing is. You see him get credited. You see Brian Cox also get credited because he showed up and did an interview on site when it happens, right? That's the same thing when Brian Cox shows up at the Sandusky vacuum chamber. Well, he doesn't know anything about the design of that thing. Nothing. He's another theoretical physicist. He just shows up. He gets credited. People automatically assume that he has knowledge of this piece of equipment or that he's part of the design, that these are the guys that dreamt it up and engineered it and designed it. They're not. And it's only because of the notoriety that they automatically attach that. So anything he says, he is now the authority in it. And when it comes to the moon landing, you, sir, are the authority in the moon landings.
Thank you.
There's no one short of that. Because anything I know, you know. Anything David Percy knows, you know. Because you are the collective source for all of the information. It doesn't matter what I decide or Jarrett White decides or anybody else decide. You have compiled all of that because you've been here longer than everybody else, and we combine our knowledge together. But you're the main source of all of that.
Purely because I've taken the time to study it, same as you have, same as Robert has. We've studied it. We've asked the questions of it. We've said, how does this work? If that happened, how does that happen? And we come up with some very strange answers. Well, if that happens, that shouldn't happen. And then we get into the detail of it, the standard stuff, the radiation, the vacuum, and the heat, the three things which are not addressed by NASA. And I think at the moment with the Artemis program, the 4 astronauts, only 4 have been named as Artemis astronauts, are probably going to start asking questions. How are we going to be protected from these dangers in space? And I very much doubt that they're going to get decent answers. I say, well, the same as we did with Apollo. Well, show us how you did it. And that's when it starts to break open. Because if they are not going to be protected as they would expect, they're probably going to find reasons not to go. Because it's a dangerous mission going beyond low Earth orbit.
They still have a problem because they haven't completed a vehicle from start to finish to even launch this thing. They've got to finish all the stages off, and they have to do all that testing and everything else just to get the thing off the ground.
And also, they're faced with a problem that has never, ever been achieved yet. In-space refueling. They don't know how many rockets they're going to need to refuel Musk's lander, which is a huge, great piece of kit. So they're going to need a lot of fuel. So they're going to have to do in-space refueling. That's never, ever been done. So they've got to do that, practice that, ensure it works. And how are they going to do that? They're going to have to launch some rockets with the fuel on board and then transfer it to another craft. That's never been done before.
With those one-time seals, that's going to be interesting, isn't it?
Isn't it just? Yeah, and they start transferring fuel between rockets. What sort of safety is going to be used to ensure that the rockets don't explode? Because refueling in space is very different from refueling on the ground, which can be controlled rather more than in space.
Aircraft have managed to refuel successfully.
Oh yeah,
but they don't need seals, and it's a different type of fuel. It's liquid, and it stays a liquid. You're in space. I don't care how you compress it. If anything's escaping, it's just going to vaporize, right? And it's just going to keep on pulling out of there very rapidly.
Yeah, and if it starts to escape, it's acting as a rocket engine. It'll start moving the craft. There are many problems before they can even attempt to land on the moon again, allegedly. Because they haven't done it the first time, they're having to go back to the beginning.
Well, Robert and I were talking a little bit earlier, and I had suggested that for the next or the first landing of anything, that because we have all of this fine technology and that we have all of these robots that have been around, like Neil says, that are always with us, that I decided the only actual robot that could have been with them was the actual Hasselblad camera, because when you took the picture, it automatically advanced the film.
Yeah.
That's a robot. That's the only robot that was available to them at the time. But if you look at the fact that they're going to make a statement that they're actually going to land on the moon, why not send out these nice robots and set cameras up that they can be sitting on the lunar surface and we can watch the descent and landing? Because these guys already knew how to do it 50 years ago. Like, look at Apollo 12. They managed to get down beside the surveyor. Well, you could put a camera down there and have it being shot from the lunar surface. And not one or two. Every country can drop one down. Have representation from every country. Have a camera down there. Their own independent cameras. You can watch them orbit, deorbit. Look at the camera technology we have today. They'd be perfect 4K images coming back from there. And we could watch it happen live on independent channels.
Well, you see, the first thing, being a human, you'd want to see your home. So you think that they would have set up a camera, at least before they left, just focused on the Earth, so that when the moon is in the proper orbit, they can control the camera, because obviously they control the camera on the rover from Earth. They had pan, they had tilt, and they had zoom. So why can't they do the same thing back in those days? Just leave a camera there, hook it up to that nuclear power pack, and you have at least 100 years worth of power, worth of voltage there. You don't see that, do you?
No, you don't. It seems to be missing from their program.
A lot of stuff is missing from their program. It's this technology, even what Neil deGrasse Tyson's talking about. If they had that technology in 1969, we would have commercial flights into space in low Earth orbit.
Yeah, of course we would.
They would be as active as any commercial airplane is running today, going from country to country. It would be that simple to do by now. It would be a tourist location. And like I said to Robert, I said I'd even go up and cook in one of the restaurants in low Earth orbit. Go to an all-you-could-eat buffet. I mean, you'll never gain any weight. And for dessert, you could have a blue marble cake. Cheesecake's as light as air.
Yeah, it'd be very good.
The famous restaurant in New York City, Le Cirque. Well, in space, it would be Le Circle. And I mean, I could go up there and I could whip your dinner up for you, and it would just be out of this world. And talk about living high on the hog. I mean, we should be there. There would be restaurants, hotels, everything else.
Yeah, well, there's still one problem that's going to put a stop to all of that, because on Monday, December the 18th of this year, an article went out from the National Aeronautics and Space Administration. This is what they had to say regarding this linear energy transfer spectrometer, which is an acronym LETS. Now, the linear energy transfer spectrometer, LETS, is a radiation sensor designed to study the lunar radiation environment. In particular, its objective is to measure the rate of incident radiation, both from galactic cosmic rays and solar events, to provide information on the hazards posed to astronauts. Now, this is a little probe that's going to sit on the lunar surface to be launched, according to these guys, on the 24th of this month. Now, wait a minute. Didn't they do this when they supposedly landed on the moon? At least once. They set up all the equipment. And, of course, they claim it's still working. Now, this little probe called the Peregrine is going to do the same thing that sensors that were placed there 50 some odd years ago are going to do. I thought we were done and dusted with this, weren't we? Why would they need to do this again when they already did it 6 times, supposedly?
If you have 50 years of recording of radiation on the lunar surface from experimental equipment that was set up there during the Apollo program, why would you need to put a new probe on the surface to record it now?
So you're going to have a new cake to make, Scott. It's called the radiation upside down cake.
Yeah.
But which way is upside down when you're in zero gravity? I'm going to have to design a recipe for an upside down cake in zero gravity.
Go for it, Scott. I think you should do that right now.
I think that is as much of a difficult challenge as spaceflight itself.
Yeah, they're beginning to find out how difficult spaceflight is.
I'm going to ask Neil to do the calculations with me, because he seems to know a lot about space.
Oh, he does, yes. One interesting comment he made during that difficult interview, I don't know if it was an interview, but his speech, he said, if peace hadn't broken out in Europe in the 1990s, they would continue spending. So it's all to do with armaments, all to do with ensuring that America was fully armed and not going to be affected by anybody else, which is a standard criticism directed towards America, that they have a defense budget higher than the next 8 countries combined. So that is the major industry in America. It's defense. Well, defense is possibly the wrong word, because it is more active.
Exactly. By the way, that interview was done at the Arizona State University.
All right. Okay. Interesting place.
And that was within the last month.
Yeah. Who is the guy sitting next to Neil deGrasse Tyson?
With the white jacket on? I'm not sure. I'd have to look that up. The bow tie guy was there, though. These guys get paid a lot of money to sit on that stage.
Well, Arizona State University obviously can afford it.
If Neil wants to talk to us, instead of throwing shit at the wall and hoping something sticks, if he wants to sit down and actually learn something, because he doesn't know anything about the Apollo program.
If he sat down and talked to us, I could guarantee you that that audience would not be laughing at every single foolish little adolescent antic that they were pulling off there. That's just wouldn't happen, because that audience would be sitting there with crestfallen faces if they did it with us.
Yeah, they would, because we would have the questions and we would demand answers.